6. And by that I mean when we start sticking numbers, we have a function like f of x, and we start sticking numbers into it, that's going to change the graph of the function. So let's talk about what all the different things do. So if I take my function, and let's just add 2 to it. Now that will create a new function. G is the new function I get when I add 2 to f. What happens to the picture in f? It goes up 2. It's called a vertical translation. It goes up 2. If that were a -2, it would go down 2, right? Okay? All the y's are going to get shifted, in this case, up 2. All right, now what happens if we take that x and add it in here? What does that do? That makes yet another function. What does it do? Moves it. This one goes left. This one goes left. This one goes left. So it would pick up whatever the picture was and move it 2 units to the left. So all of the x's, if f contained the point, let's say 1, 3, this would turn that point into 1, 5, and this would turn that point into -1, 3, right? Takes everything left 2. All right. What happens if we put a multiplier on our function? A multiplier, not an add or subtract. Adds and subtracts move you. They're called translations. A multiplier is called a dilation. What does it do?
Make like the slope like
Makes
greater.
it steeper. So this one, all of the y's, literally f of x is y. So all of the y's are going to get doubled. So if that was the point on the original, the new point would be 1, 6, right? And then the last one, I guess there's a couple more. But the last one is what happens if we put that multiplier inside the parentheses. It what?
It like fly, like push it down.
It actually
Double flag.
it doesn't widen it. It actually halves it. It shrinks it. It shrinks it by a factor of a half. Okay? Now, before you get all confused, you knew that already, I think. But before you get all confused, stop and think. What does this look like it should do? It looks like it should
Move it to the right.
add 2, right? But what does it do instead? It goes backwards. What does this look like it should do? Multiply by 2, what does it do instead? Halve it. So that point would be 1/2, 3, if that was on the original graph. Okay? And then the last one here on the sheet, just as kind of the basics, what happens if you put a negative out there? So what if we had a negative f of x? What does a negative in that position do? Upside down. Upside down. So I'm the x here, my arms are the x-axis. It goes from here to here. So if that was the point, 1, 3, it would now be 1, -3. Upside down. And then a negative inside does what? It's a reflection. These are called reflections, but it's a reflection across the y-axis. So it goes from here to here. So that point would be -1. Okay? Everybody okay? Basic rules there? All right, so now we're going to look at example 1. We have some weird thing drawn there. The picture's drawn. And the picture is called f, so that is our base function, f of x. what are the domain and range of f? So function f, what is the domain and range for function f? What's its domain? Negative 5 to 5. No arrows, right? So we're stopping and starting, negative 5 to 5. What is the range of f? Negative 3 to 3? Yeah. That okay? Again, no arrows. Now, we're going to make a new function out of f. We're going to take f, put a 2 there, a minus 1 there, and a 3 there. So in other words, what are we doing to f? Well, what does this do? All the x's go right 1. I'm just writing that down in words. Is that what happens? That's an x movement. That's impacting the x's. What do these guys do? Well, that's going to double your y's and then add 3 more on top of that. So we're going to double the y's and add 3 more. PEMDAS rules apply. We double and then we add. Multiply and then add. So then the question is, what does that do to the domain and range for G? Well, the original domain was negative 5 to 5. And the only change we made to x is we took everything right 1. So what's our new domain? Negative 4 to 6. We took those guys right there and went right 1. Now what about my new range? Well, what did we do to the y's? Range of y's. What did we do? Well, we doubled these and then added on 3 more. So if we double those, we get negative 6 to 6. But if we add on 3 more, where will we end up?
Negative 3 to 9.
Negative 3 to 9. So now we have some random point on F. So this is a point on F. And we want to know where the corresponding point on G will be. Well, remember, right here, you told me how it's changing. What's happening? All the x's go right 1. So if you take that right 1, it's going to be at 5. Now what are we doing to the y's? We're doubling them and adding 3. So that would be, let's see, double that would be 4, 7 would be the corresponding point on the graph. So far this seems easy enough. All right, find G of 0. Remember, G is this one that's all moved around. What do you think? What?
Plug in x to 0.
Where would you plug in 0 for x?
And x minus 1.
Right here?
Yeah.
All right, then what's it going to say? We plug 0 in right here. If we say, all right, we're going to let x be 0, I'll put it right there. What would that say? 2f of negative 1 plus 3. All right, what's f of negative 1? I need to look at my picture. F of negative 1 is 3. How does that look to everybody? What do you think? Was that good logic? That makes sense? The whole picture went right one, right? Right one. So whatever is happening at 0 for G happened at -1 for F, didn't it? Because it got moved right one. So I think that's great. I think that's perfect. How many solutions does the equation g of x equals 0 have? Okay, that's different now. That's g of x equals 0. How many solutions does that have? Remember, this is g. How many solutions does that have? Any ideas about that? Al?
Could we set 0 equal to 2 f of x minus 1 plus 3?
It says g of x is 0, so g of x is that. You're exactly right, Al. So let me subtract 3 and divide by 2. Look at your picture. This is F now. This is F. Does the picture ever equal -3/2? Does it ever equal -3/2?
Yeah.
Where does it equal -3/2?
It's like -2.5.
At about -2.5 or so? In there somewhere?
Yeah. Maybe like 2.75.
So the question says, how many solutions does it have? How many times does it equal -3/2? Just once. So how many solutions does it have? One. One. And then finally, on what intervals is this guy increasing? Now remember, you have F drawn here. Does G have the same basic shape as F?
Yep.
Yeah. So does it make sense to you that obviously F is increasing places, that G will be increasing the corresponding places? So let's figure out where F is increasing. Where is F, the original picture, where is it increasing? From where to where? -4 to -1, okay. Anywhere else? 1 to 4. Would everybody agree that that's where it's increasing? Now, these are x's, right? These are x values. What is our function doing to x values? Moving them 1 unit to the right?
3 units up.
No, wait. These are x values. These are not points. These are x's. We are increasing from -4 to -1. So what would that be, that corresponding interval on our g function? -3 to 0. And then this one would be from 2 to 5. G is going to increase just like F does. Only 1 unit to the right. All right. And we're moving on to example 3. So anything still about example 2? 3 is kind of the same. Declan?
How is it 2 to 5? This Was the Y? I thought the Y was double and then you add.
Okay, wait, this isn't an ordered pair, these are X values. These are from here to here. So the Y's are not part of that conversation. These are intervals of X's. These are not points, you guys, these are intervals. We're going up in that section. If I double and all that stuff, the height, it isn't gonna matter, it's still gonna be going up in that corresponding section. All right, is that all right? Okay, now let's look at, we're using the same basic function. Only what are we doing now? We are let's go ahead and write down what are we doing. What are we doing to our x's? What's happening to our x's? They're going left 3, right? So every x that we talk about in F is going to go left 3 for this one. All right, and then what's happening to our y's? Well, what's is happening to the y's? They're being multiplied by -2, which is going to do what? The y's are going to go from up here to down here. And then we're multiplying by -2, and then go down another one, down 1 from that. Okay, so what's the new domain and range? What's the domain and range for our new function? Well, here was the domain of the original. If we go left 3, that's easy. Our new domain will be what? We're going left 3, so it'll be negative left 3. So it'll be -8, 2. Right, guys? Now, what about our range? Well, remember what you're doing. You are multiplying by -2 and going down 1. So if we multiply by -2, that'll make 6 and -6, right? And if we go down 1, we'll be at 5 and -7. But when you write that, be careful. You can't write them in that order. You'll have to write -7, 5. That will be your range. Because every time you write an interval, every time, you have to have a little and then the big. Okay? Now, what about this next one? Where is H? So all the questions are about H, which is not what's drawn. Where is H going to be concave up? Well, let's look at F. Where is F concave up? F is concave up where? From -5 to maybe -2. And then it's concave up again from maybe 0 to 3. Would you agree with that? That's where F, the picture, is concave up. Let's go ahead and do down. Where is it concave down? Where is F concave down? -2 to 0. And 3 to 5. Everybody okay with that? that's F. All of these are X intervals. So they're all gonna be moved left 3. So that interval is gonna become -8, -5. Would you agree? And everything's gonna do the same thing. These are all X's. Everything up there is an X. And it's all going that way 3. But I'm a little bit concerned about something. What am I thinking about? I want H to be concave up. Declan?
Would all the concave down become the concave up because it's reflected over the x-axis?
Remember we tipped it upside down? So if it was concave up, when you flipped it upside down, it became concave down. So if we want to know where H, where our new function is concave up, we're going to have to look where the original is concave down and then back it up 3. So that would be -5 to -3 or 0 to 2. How about that? That's where H is going to be up. H is going to be up, concave up, where F is concave down because we tipped it upside down. Normally that wouldn't be the case, but we tipped it upside down. All right, everybody hanging in there? All right, next. On what intervals is H increasing? Take a couple minutes. What does increasing mean? Going up. So clearly you can look at F and tell where it's going up. But your job is to figure out where is H going up. So take a minute, talk about it with your friend. Now, you all have your own ways of doing it. I went ahead and just wrote down from the picture, here's where F is increasing and decreasing. That's where F is going up or down. Now, the question though was about H. What do you think? What did you guys come up with for H? Scout?
So you just need to find where it's decreasing.
Remember, we tipped it upside down. So does it make sense to you that if the original is decreasing, H will be increasing? Yeah? Does that make sense to everybody? Remember, you tipped it upside down? So we want to know where H is increasing, so we are going to look right here. But remember, those are F's, X's, and all of our X's got moved left 3. So G will be increasing all of these left 3. So -8, -7, -4, -2, keep an eye on my arithmetic. And 1 cube, is that right? That's where G is increasing. In that picture I said down. Valleys become hills. Is that right? All right, now we have to find any solutions to h of x equals 5. We did one like this a minute ago. Isn't this h of x? So we're just going to set that equal to 5 and solve it. So here we go, negative 2, 6, f of x plus 3 equals, did I do okay so far? Now what does this say? This says f of something is negative 3. Look at your picture. Is f ever negative 3? Where is it negative 3? At negative 4? So the something has to be negative 4, which means x has to be what? Negative 7? Because that's the only place where your function gets down to negative 3.
Where did you put the negative 3 after that?
What? So the y value is negative 3. Where on your picture is the y value negative 3? Okay, but it's got to go 3 units to the left, because in h, everything goes left. So that puts me at negative 7. Right? The only place in the picture where the y value is negative 3, in the original picture is at negative 4, but everything got shifted 4 units to the left. Okay. All right, example 4. What is going on here? I've got 2 functions, m and n. M is my original, and n is negative 3m 2x plus 5. All right. Table for n. Alright, so we got some stuff to fill in. Did I get it all in there? I think so. Alright, find the missing values. Anybody have an idea? Mark?
Are the x's divided by 2?
What?
Are the x's all divided by 2?
They're going to be, now I gotta fill in this chart, but yeah, to get from the original equation to this one, yeah, that's gonna shrink my x's. I think, no one's saying anything, but I think you might be like don't know, are you overthinking this a little bit? At least some of it. So what does this mean? You're gonna find m of x. Your job is to find m of x. What are you gonna do? Yeah, we need to find what, yep, Al.
So like for when it says, like for the ordered pair 1, 3, could you plug in for n of 2x, would that be 6? Like could you plug it into the equation to get n of x?
Or could you plug in 0 for n of x?
Or would that not work?
Well, anything can work maybe, I don't know, we have to see. So, I think I understand what you're saying, Al. Let's look here. This is the n, this is my n table. That's my n equation. If x is 2, if I'm finding n of 2, won't I just put a 2 in here? So that'll say n of 2 will equal negative 3 m of 4 plus 5. Do I know m of 4? M of 4. So keep your letters straight.
Yes.
Okay, so there's nothing magic or hard about this. Here is my n function right here. If I let x be 2, so I'm finding n of 2, put a 2 in, negative 3 m of 4 plus 5. What's m of 4?
5.
M of 4 is 5. So it looks like what's going to go in here will be
Negative 15 plus 5. So negative 10.
negative 10. I'll do it in red so we keep it straight because I have a lot of different calculations. Is that okay? Could I do the same thing here?
Probably.
So I'm going to plug 4 into my n function. So n of 4, I'm finding n of 4 will be negative 3 m of 8 plus 5. Plug it in, just plug it in. But do I know m of 8?
Yeah.
Here's your m. Do you know m of 8? Negative 12. So that one looks like it's going to be 41. Would you agree with that? Okay. All right, let's continue on that same thing. What does this ordered pair right here say? It says that if you plug in 0 for x, you're going to get negative 4, right? So negative 4 equals negative 3 m of 0 plus 5. I'm plugging in 0 for x, and it's all going to equal negative 4. So negative 9 equals negative 3 m of 0. 3 equals m of 0. Isn't that what I was looking for? M of 0. So that's 3. Could I do the same thing here? So let's come over here. Let's see. Now I got to be careful. I got to be careful because I need x to be 2. And if I need this x to be 2. If I let x be 2 in this equation, I'll be finding m of 4. So what if I let x be 1? in my equation. Then it would say n of 1 equals negative 3 m of 2 plus 5. Would you agree with that? This equation, I put a 1 in for the x's. Now, why did I put a 1 in? Because what am I looking for? M of 2, and that's how I got it. So what's n of 1? N of 1 is 0. So it looks like m of 2 is going to be a fraction. M of 2 is going to be 5/3. I think some of you are a little bit confused by that because we're supposed to be letting x be 2. In the original problem, we're supposed to be letting x be 2. Do I have an equation for the original problem? Do I have an equation to plug into? No. So I had to build it so that this would give me m of 2 so I could fill in that blank. See what I'm saying? I couldn't plug in 2 because then this would say m of 4. I needed to say m of 2. So I had to put in a 1. That's the only equation I have. I don't have an equation to plug m into. All right, all the blanks filled? Good. All right, next page, here we go. More fun with transformations. Gotta love Mr. Passwater.
John Wick has the Missouri.
No, Gus are.
John Wick. Gus is second.
Wait a minute. Hear me out.
All right, so
Monty
F
Wilson.
is a polynomial function.
He invented the money square.
He's Mr. Beast,
He
right?
invented the money square.
Yes, someone. Yes, someone.
G is f of negative
There's
x.
no one going out.
All right, so let's write down in words just to see it. What does that mean? What has happened to G?
Negative x is become positive.
All the points are reflected across what? Which way are they going? Across the y-axis, right? So in other words, the sign on x is changing. If you were over here and you were positive 2, now you're over here, so you are negative 2. Right? Where are the zeros of the original? F's zeros are where? X equals -3 and x equals 1. Those are the original zeros of the polynomial. Question is, where are the new zeros then? Where are the zeros for G? Well, all the points are reflected across the y-axis. The sign on all the x's changed. So where are the new zeros? X equals 3 and x equals -1.
You don't have to say that there's a multiplicity or anything.
What?
You don't have to say there's a multiplicity.
No. I mean, you can, but the multiplicities are going to match what the originals were. On what intervals is G increasing? Now, they didn't give us a picture of the original like they did before. Could we draw the original? Could you draw this? Sure you can. You have zeros, I'm looking at the original now. I have zeros is -3 and 1. What's the degree of that polynomial? 3. Odd. Starts down, except it's upside down, so it's actually going to start up here. What does it do when it gets to negative 3? It bounces and comes down. So would you agree with that picture? Is that okay? All right. On what intervals is G increasing? Now, remember, we tipped this upside down. So won't G be increasing where the original was decreasing? Oh, wait, no, we didn't go upside down, we went sideways. Oh, no, we went sideways, I'm sorry. We went sideways, not upside down.
How do we know, like, where it changes from increasing to decreasing?
Well, that's a good question. We could use our calculator. Let's try to answer the question. We are flipping this way. We're flipping this way. So what's our picture going to look like? Well, it's going to be over here at 3 and here at negative 1. Now, that one has the multiplicity now, right? So that's my bounce. So I went this way. So now it looks like that. Did I graph that right? Is that what we're saying? So this is my new picture. And I want to know on what intervals that is increasing. Okay, well, I know this one's easy. What's that one? 3 to infinity, that's easy. This one, I'm just gonna random eyeball it, because without a calculator or knowledge of calculus, I can't find that. So I'm just gonna go ahead and eyeball it and say it's about 1. So we're increasing from negative infinity till 1. And then again from.
So is there not a way to, like, find that number without
There.
a calculator?
Using a calculus skill, yeah, but not without that.
So on, like, a quiz, we would just estimate?
Mm-hmm. Yeah. Okay, all right, where am I now? Example 6. Let H, okay, I think I'm using the same function, am I? I think I'm using the same function. So now H is 2f of 3x minus 5. What do I want to know? Find H of 1. Well, that shouldn't be too bad. H of 1 will be 2f of 3 minus 5. And we'll go back to the original. What's f of 3? F of 3 will be, oh my, something quite large. F of 3 is, what is that, negative 144, but I have them all, so negative 288 minus 5, did you get negative 293? That was the age of 1. What? Yeah, we're going back to this one. So I put in 1, or no, I put in 1 for X, and that gave me 3.
2 million.
So 2 after 3, I put in 3s here. And it seems very large. All right, well, I guess we're getting ready to pack up, so I'm gonna stop there. And I will see you guys next week. To do more of this fun, exciting stuff. Sit down, Kellen O'Brien.